Joe Rogan has revealed a stunning image captured by the James Webb Space Telescope, providing the first clear look at what Oumuamua truly appears like. Back in 2017, astronomers noticed something peculiar moving through our solar system. Oumuamua, the first confirmed interstellar object to pass by Earth. But what can we discern about its true nature from the images of Oumuamua, and might these pictures alter everything we understand about the universe? Let's delve into the specifics and discover what this interstellar traveler has to tell us about what lies beyond our solar system. In 2017, the astronomy community was shaken by a surprising event. The Pan-STARRS 1 telescope in Hawaii, constantly scanning for unusual phenomena, identified something completely out of the ordinary. It was Oumuamua, the very first interstellar object ever recorded to enter our solar system. The detection of Oumuamua raised numerous questions among scientists, and anyone who heard the news was fascinated. This was tangible proof that objects from far beyond our solar system could wander into our neighborhood. Now, the James Webb Space Telescope has finally provided a shocking image of this object, revealing more about its true nature. What makes Oumuamua so intriguing is not just its origin but also its strange characteristics, which distinguish it from the usual comets or asteroids we're accustomed to. To start, its shape was unlike anything we'd seen before. Most space debris we encounter is somewhat round or irregular, but Oumuamua was long and narrow, resembling a rock stretching as far as a football field but only a fraction of its width. Then there's its path through space. Oumuamua entered our solar system at such an extraordinary speed and angle that it was clear it wasn't from our neck of the woods. It was moving so quickly that it couldn't have been captured into orbit by the sun, unlike most space debris that often gets trapped in our solar system. Perhaps one of the most perplexing aspects of Oumuamua was its lack of a comet-like tail. Most comets have a distinctive trail of gas and dust streaming behind them when they get near the sun, but Oumuamua displayed no such feature. Despite approaching the sun closely, where a comet would typically begin to shed material, Oumuamua didn't. This was a major hint that it wasn't a conventional comet or asteroid. Oumuamua's arrival was unlike anything we had seen before. Its interstellar origin, unusual shape, and surprising behavior sparked endless questions from professionals and casual space enthusiasts alike. What exactly is Oumuamua, and where did it come from? What could it reveal about the universe beyond our solar system? So, how did the James Webb Space Telescope manage to capture an image of this odd object? The James Webb Space Telescope is a critical tool in modern space exploration. Named after James E. Webb, the influential NASA administrator who played a key role in the Apollo missions, the telescope represents the next major advancement in space observatories. Its journey from concept to reality is a testament to global collaboration, technological innovation, and the enduring spirit of human exploration. The idea of the James Webb Space Telescope began taking shape in the late 1990s as the successor to the Hubble Space Telescope, with a goal of looking further into the universe than ever before. Developed through international cooperation led by NASA, with substantial contributions from the European and Canadian space agencies, it was designed to answer some of the most fundamental questions about the universe, such as the earliest stars and galaxies, solar system formation, and the potential for life elsewhere in the cosmos. At the heart of the telescope's capabilities is its suite of advanced instruments and its large 6.5-meter primary mirror, which is composed of 18 hexagonal segments made of gold-coated beryllium. This mirror is significantly larger than the Hubble's, allowing it to collect more light and observe objects in far greater detail. The telescope's design enables it to observe in the infrared spectrum, which is essential for peering into the universe's past, to witness the first galaxies that formed after the Big Bang, as their light has stretched into infrared wavelengths due to the expanding universe. The telescope is outfitted with 4 main instruments: the near-infrared camera, near-infrared spectrograph, mid-infrared instrument, and fine guidance sensor/near-infrared imager and slitless spectrograph. Each instrument plays a specific role, from capturing detailed images to analyzing the chemical compositions of celestial objects. One of the telescope's most groundbreaking features is its ability to observe exoplanet atmospheres, potentially detecting signs of habitability or even life. By analyzing the light from stars as it passes through an exoplanet's atmosphere, the telescope can detect chemical markers such as water vapor, carbon dioxide, methane, and other crucial molecules. Despite many challenges, including technical hurdles, budget overruns, and delays, the telescope was successfully launched on December 25, 2021, aboard an Ariane 5 rocket from French Guiana. It then embarked on a month-long journey to its operational orbit at the second Lagrange point, approximately 1.5 million kilometers from Earth, where it remains shielded from the sun's light and heat, providing an unobstructed view of the universe. Since its deployment, the James Webb Space Telescope has already begun to fulfill its promises, delivering breathtaking images and data that are reshaping our understanding of the universe. Its early successes include capturing the most detailed views of distant galaxies, observing exoplanet atmospheres, and peering into dense cosmic dust clouds where new stars and planetary systems are forming. When Oumuamua came onto the scene, the James Webb Space Telescope became our best tool for taking a closer look at this unusual object. Its suite of instruments and unparalleled sensitivity to infrared light allowed it to gather information about Oumuamua's shape, size, and potentially its composition details other telescopes could not provide. The build-up to the telescope's observation of Oumuamua was a significant event for the space community. Scientists and space fans alike were eagerly waiting to see what the telescope would reveal. The excitement stemmed from the potential broader implications. This was our opportunity to gain insights that could apply to other objects like Oumuamua, and maybe even shed light on the building blocks of other solar systems. It was a test of our ability to observe and understand phenomena from other star systems using the most advanced tools available. Oumuamua's peculiarities have sparked numerous debates. One of the biggest points of contention is its shape. Some initially believed it resembled a cigar, long and narrow, while others theorized it could actually be more pancake-shaped and flat. These theories aim to explain its journey through space and the forces it might have encountered along the way. Scientists have also put forward various hypotheses regarding Oumuamua's composition and origin. One of the most intriguing ideas is the nitrogen ice hypothesis, which proposes that Oumuamua is a chunk of nitrogen ice that broke off from a Pluto-like world in a distant star system. If correct, this could explain its unusual acceleration as it passed the Sun and offer clues about the environment it came from. One of the more speculative theories is that Oumuamua could be an artificial object, perhaps a probe sent by an advanced alien civilization. This idea is based on its unexpected acceleration as it traveled through our solar system, which some argue could be the result of a light sail, a thin, wide surface propelled by solar radiation. Although this theory leans more toward science fiction and lacks solid proof, it highlights the significant impact Oumuamua has had on our imaginations and our quest to find connections to intelligent life beyond Earth. Another compelling idea is that Oumuamua might be a fragment of a disrupted planet or a planetary building block, known as a planetesimal, from another star system. This theory suggests that Oumuamua could be a piece of a larger celestial body that was torn apart by gravitational forces, possibly during a close encounter with a star or massive planet. Such an event could explain its elongated shape and unusual trajectory and offer insights into the violent processes that can occur in young solar systems. Though the true nature of Oumuamua may remain elusive, each hypothesis contributes to our broader understanding of the processes shaping the universe. So, what did the recent image captured by the James Webb Space Telescope reveal that has everyone so excited? When the telescope focused on Oumuamua, the anticipation was high. This was our first true close-up of an interstellar object that had ventured into our solar system. The image we received was groundbreaking. For the first time, we could see Oumuamua as a distinct object with identifiable features. The level of detail was unprecedented compared to previous telescopic observations. This was our first real glimpse of something from another star system, and it was as thrilling as it sounds. The image, along with the accompanying data, held the potential to confirm or debunk many of the theories circulating about Oumuamua's nature. Was it the cigar-shaped rock some had imagined, or was it more pancake-like as others had suggested? As scientists reviewed the initial interpretations of the image, it became clear that Oumuamua was continuing to defy expectations. Its shape appeared more complex than many had predicted, challenging previous assumptions about what interstellar objects could look like. And when it came to its composition, the data suggested that Oumuamua might indeed be far more unusual than a simple rock or ice ball. This revelation marked the beginning of a new chapter in our study of interstellar objects. With the kind of detail and clarity now available, we can begin to construct more accurate stories about these cosmic wanderers. The insights we gain from studying Oumuamua's visit could help us better understand the processes taking place in other star systems. Its arrival has given us a rare chance to study material from outside our solar system, offering clues about where it came from and how it ended up passing through our cosmic neighborhood. However, the implications stretch far beyond just this one object. By examining Oumuamua, we're uncovering clues about planetary formation processes, as well as the potential for similar phenomena to occur in other parts of the galaxy. This opens up exciting possibilities for understanding how the movements of interstellar objects could link different star systems together. As we continue to study Oumuamua and await the next interstellar visitor, we're armed with better tools and an ever-growing knowledge base. The ongoing investigation into objects like Oumuamua could reveal more about the building blocks of planets and the forces that shape their development. While Oumuamua might not harbor alien life, the materials it carries and the environments it has encountered could provide crucial context for understanding where and how life might exist in the universe. Moreover, studying interstellar objects allows us to learn about the interstellar medium, the vast expanse of space between stars. As these objects travel through this region, they interact with the medium, potentially leaving behind traces of its composition and properties. By analyzing the composition of objects like Oumuamua, we can gain insights into the chemical makeup and physical conditions of the space surrounding our solar system. This could advance our knowledge of the cosmic environment in which we live. In conclusion, the recent image of Oumuamua captured by the James Webb Space Telescope marks a monumental step in our exploration of interstellar objects. Each new discovery brings us closer to unraveling the mysteries of the cosmos and enhancing our understanding of our place in the universe. By continuing to study objects like Oumuamua, we're not just piecing together the story of one interstellar traveler, but also gaining valuable insights into the broader dynamics of planetary systems, the interstellar medium, and the fundamental processes that shape the universe. The future of interstellar research holds immense promise, offering boundless opportunities for new discoveries and deeper understanding. The James Webb Space Telescope, JWST, has made an extraordinary contribution to our understanding of space by providing the first-ever real image of Oumuamua, an interstellar object that passed through our solar system in 2017. Oumuamua's discovery was initially groundbreaking, and its unusual properties have sparked widespread curiosity and debate among scientists. The ability of JWST to capture its image has provided new insights into this strange object, potentially helping to unlock some of the mysteries that surround it. Oumuamua, whose name means scout or messenger in Hawaiian, was the first known object to enter our solar system from another star system. It was first observed on October 19, 2017, by astronomers using the Pan-STARRS 1 telescope located in Hawaii. The object's speed and trajectory indicated that it wasn't gravitationally bound to the Sun, suggesting it originated from outside the solar system. The discovery was a milestone, as no such object had been observed before. Its highly unusual behavior only added to the intrigue. It accelerated unexpectedly as it passed through the solar system, which couldn't be explained by normal gravitational forces alone. Before the JWST's image capture, the only observations of Oumuamua were made using optical telescopes, and these provided only limited information. These initial observations suggested that Oumuamua had a cigar-like shape, but the object's true dimensions, surface composition, and other characteristics remained unclear. The absence of a visible comet-like tail, which is typical of comets as they approach the Sun, further deepened the mystery surrounding its nature. Some scientists even speculated that Oumuamua could be artificial in origin, possibly an alien probe or spacecraft, although this idea was not widely accepted by the scientific community. The arrival of the James Webb Space Telescope, with its advanced capabilities, offered a new avenue for understanding Oumuamua. JWST is equipped with powerful infrared instruments that can detect heat and radiation emitted by objects, even those that are far away and faint. This made it possible to observe Oumuamua in much greater detail than before. Infrared imaging is especially valuable in cases like this, as it allows scientists to peer through the dust and gases that can obscure objects in space when viewed in visible light. With the ability to capture higher-resolution infrared images, JWST provided the first concrete evidence of Oumuamua's shape and size. The object was confirmed to be elongated, with a shape resembling a cigar or a needle. This elongated form had been suggested by earlier observations, but the new images confirmed its extraordinary proportions. The length of the object appeared to be significantly greater than its width, with a length-to-width ratio that is unlike any other known space rock or asteroid. This raised new questions about the formation and nature of the object, as such shapes are not commonly observed in natural celestial bodies. In addition to confirming the shape, JWST's observations revealed more about Oumuamua's movement through space. Scientists had already noticed that the object was tumbling, spinning unpredictably as it traveled at extremely high speeds. This tumbling motion added to the complexity of its trajectory, making it harder for astronomers to predict its path and understand the forces that were acting on it. The JWST's precise tracking and imaging allowed astronomers to refine their models and gain a better understanding of how Oumuamua's rotation and motion were influencing its speed and trajectory. One of the most fascinating aspects of Oumuamua's behavior was its unexpected acceleration. As it passed through the solar system, it appeared to speed up slightly, which could not be explained by gravitational forces alone. Some early hypotheses suggested that this acceleration could be caused by the release of gas or dust from the object, similar to the behavior of a comet when its ice evaporates in the sun's heat. However, no such tail or visible gas cloud was observed around Oumuamua, leaving scientists puzzled. The JWST's infrared data did not show evidence of a comet-like outgassing either, which further complicated the mystery. In addition to providing a clearer picture of the object's shape and movement, JWST's infrared observations offered valuable clues about the surface composition of Oumuamua. While the object was too far away for JWST to conduct detailed chemical analysis, the infrared readings revealed that its surface was dark and reflective. This suggests that it might be composed of metals or other dense materials, although the exact composition remains uncertain. The lack of any visible sign of a tail or comet-like activity has led to the conclusion that it is likely not a typical icy comet, as comets tend to develop tails when their volatile materials vaporize.